Okay, so let's look at the next problem. This one wants to find us the Norton equivalent circuit. Excuse me. So if we look at this here, we've got not one but two sources. And we've got two different resistors. And then over here, we have plus minus VOC. So to find our Norton current, or Norton circuit, that's going to require that we have I of N and R Thevenin. So we're going to need to find I of N, and we need to find R Thevenin. Okay, so let's go through our steps. So step one, are there any dependent sources? No. So I don't see any diamonds, so we're good there. Step number two is we will now zero out our sources. Or we'll take that battery, turn it into a wire. The current source will turn into a clipped out piece. So let's go and redraw our circuit over here and see what that would look like. All right, and then if I go and drop my imaginary wire here, it's VOC, plus minus. And like we said, we're going to act like that's a battery source. Okay, so now we can see that we replaced the current source with an open wire, and we replaced the battery with a regular wire. Okay, so now let's see what it looks like whenever we are going to send current through here. The current will leave this imaginary battery, go that way. It'll bypass that open terminal because it can't make that jump across the open wires. It'll come this way, and then now it'll split off into those two directions. It'll meet back up and repeat the cycle. Okay, so now we're working towards that way to find our equivalent, which would give us our R Thevenin. We're working towards the open terminals. So if we look, we see that these two are in parallel. So I'll call that R parallel 1. That'll be 15 times 25 over 15 plus 25. And this will give us 9.375 ohms. And if we were to redraw that over here, R parallel 1. VOC plus and minus. Okay, and we see that if we were to send current through here, the current would just pass through that one resistor. So therefore, R equivalent is equal to R Thevenin, which is 9.375 ohms. Okay, so that's the first part. The next part, we need to find the I short circuit. So to find the I short circuit, what we need to do is we've got a couple options, but what we're going to do is go back to our original circuit. This is step 3, by the way. Find RThev. Okay, step 4. Back to OG circuit. And if we had plus minus 10 volts, 1 amp, 25 ohms, and 15 ohms. Okay. And if we take a look here, here, drop these in here as well. So if we still had our imaginary wire here, we still had our imaginary wire. For Norton, if you're trying to find the current through this wire, so I short circuit, which is equal to I Norton, when you go back to the original circuit, you're going to want to still keep that imaginary wire in there. Whereas if you're trying to find the voltage, ignore it. And we'll see what this looks like in just one sec. So if I got 1 amp coming up that way, and I've got this battery source that's going this way, going like that, and it gets to this junction here and it sees it has 2 options. It can either go down where there's resistance, or it can travel through this way, there's no resistance, and then keep traveling down this way, just where there's absolutely no resistance. So that's what that current's going to do. It's basically just going to bypass that resistor because it doesn't want to take any resistance on whatsoever. So what we can do is we can find out by doing a KBL on it. So here, if we did walk the big loop, the outside loop, like that, we did minus V of S plus I1 15. I'm just going to call this one I1. That'll equal 0. So therefore, we can say I of 1 will be equal to V of S over 15. I of 1 will be equal to 10 over 15, which should give us 0.67 amps for I of 1. Okay. And so now we know that 0.67 amps goes in that way. We know 1 amp goes that way. And if we were to add those together, 0.67 plus 1 amp, 1.67 amps. So those two make up this one. All right. So our I short circuit is going to be equal to 1.67 amps. And I short circuit is equal to I Norton, which is 1.67 amps. Okay. So now we can come down here and we'll redraw our circuit. So if we're doing the Norton, remember I Norton is going to be in parallel with the R Thevenin, and it's going to have these open terminals where this will be plus minus VOC, and we found that I Norton is equal to 1.67 amps, and then R Thevenin is 9.375 ohms. And that's just our uh, Norton equivalent circuit.